Okay, we're gonna turn this nitrile into an amide, then we're gonna turn into a carboxylic acid. Um, I'm gonna go through every single part of this mechanism, every part, like if you're gonna go to the exam, like how you supposed to be thinking about it. Okay, so we're in basic conditions. Every time we see NaOH, we're in basic conditions. So let's just start off. Let me try to be neat in this one. Okay, right here, we make it a carbon actually. Okay, OH, he's negative. Every time you have a negative, and when you had a positive thing, so in the other example, we're in acidic condition. So this entire mechanism for the acidic condition, now we're in basic. So you could see, like, you could look at the difference and try to see, like look at the difference basically. So in the other example, we did acid base first, but we can't form a positive charge because if we did acid base, imagine we did acid base right here. This is gonna form a positive charge on nitrogen. So this is gonna we have to form a negative charge. So this is gonna go onto the carbon, and this is gonna go onto nitrogen. So now we form this compound. I mean, I'm gonna get rid of the carbon, and we form this carbon compound right here. So now nitrogen, um, he actually doesn't even have a hydrogen. He's just like this, and he's negative. So what do you think is gonna happen now? So we just formed oh, right here, right? This is how it's gonna be. Yep. Now what do you think is gonna happen, right? We just honestly, I don't even know what's gonna happen. I'm trying to figure it out right now. We attack it with nucleophilic addition first, then we move the bond to nitrogen. Now nitrogen looks like he's kind of angry right now, right? So he's probably gonna attack something. Um, question is, what is he gonna attack? Uh, if he attacks water, there is water in the flask, right? So let's see if it attacks water. I feel like that makes the most sense. So now nitrogen, um, he'll be normal, right? And he's not gonna have any charges. See, that makes sense. Now what's gonna happen? If we just attacked water, that means we have hydroxide formed. So hydroxide is gonna attack something and it's gonna do acid base. So the question is, who is he going to attack, right? Um, so you have to ask the question. We have to find the most acidic proton. There's a proton on nitrogen and there's a proton on oxygen. Now the question is, who will prefer the charge? So if we attack oxygen H and we put it on this, or are we gonna attack with this color? Are we gonna attack this H and put it on the nitrogen? Question is, who wants to charge more? Oxygen is more electronegative. CNO. Oxygen is more electronegative, so he wants the negative charge. So he's gonna attack the oxygen. So oxygen is gonna get the charge on it, um, and he's gonna be like that, and nitrogen is like that. So now what we can do is it seems honestly I'm trying to figure it out right now. Okay, nitrogen is like that, oxygen is like that. What if we move this right here? I don't know. I'm guessing. If you move that there, and then we push it onto nitrogen. Our goal is to make an amide, right? Our goal is to make an amide, so I feel like we need this guy to be honestly. It made sense when I was doing it without the camera. Now I'm selling. Alright, it's fine. Okay, nitrogen. Wait. I'm bugging. We just formed water, right? Water's formed here is probably gonna be in some use. So let's write the water here. Okay, let's see. But wouldn't oxygen attack the water and then it would go back? Hmm. What if we move this bond here? And then nitrogen will attack the water right after that. Maybe that makes sense. Let's see if that works. And now nitrogen has it, and then now he's more likely to, because if you attack the water, we go back, right? So we'd rather have nitrogen attack the water. Nitrogen attacks the water, and then now, like, oh, we formed it. There's no way this is the answer. See, I just figured it out. Okay, yeah, this is how you do it. We formed. Is this the answer we formed? Um, pH, NH. Yeah. That's the answer. That's good. Okay. You saw me how I figured it out. Um, because listen, this is the most confusing part. Because like, why wouldn't oxygen attack the water? But if it attacks the water, we're gonna go back to the same spot. So if we want our answer to look like, yeah. So okay, we formed our we formed the amide. So now we're gonna form carboxylic acid. So yeah, I'm gonna just do it under here. Let's see if I can use a different like smaller ones, if I can fit everything in one page. Okay. Um. The reagents are H2O. No, it's NaOH, H2O, H2O, and then H plus, and then H2O. Okay. What's gonna happen? Same thing, honestly. Same thing. It's gonna be nucleophilic addition. So, OH is gonna it's gonna go into that. We're gonna form the tetrahedral intermediate. I think this is just saponification. Not sure. I think it is saponification. Yeah. So now this is gonna have it's gonna have the OH, and then this is gonna be the N. Let me make it look more geometrical. Alright, like that. Okay. Now this is the tetrahedral intermediate. We have a good leaving group. N is a good leaving group, so he'll leave. Elimination. So now we'll have this, and we'll have our answer. Psych. This is not the answer. Yeah. Listen, it looks like the answer, but um we need to do some stupid step that I don't even understand why we do it, because we already get the answer. But I always remember, because this part is always like, why the hell are we doing it again? So what's gonna happen is that this oxygen is gonna get deprotonated. So it's gonna get like take the Na, the N that we just formed is gonna take that H. I don't even know why this happens. I mean, obviously there's obviously like a reason. I'm just ignorant, but it's gonna be like this. Okay, this is gonna have a negative charge, and he's gonna take that. If you want to write the pKa of a carboxylic acid is equal to 5. Okay, so now we're gonna do acid base right here, and we're gonna get this. We're gonna get the. Maybe we're getting this thing is because we're in negative, like since we're in like in a since we're in a basic environment. That's probably why this happens. Like it's gonna be like made negative, right? Because we're in a basic environment. That's probably why this even occurs. So that's probably why it happens, and then you're gonna form NH3. I think NH3 is like his pKa is something like, I think it's like 36 or 35 or 30. I'm gonna guess that it's 30, but you can search that up later. I'm gonna just do it right now. I'm being lazy. I have it on me. pKa is 38. 38. Honestly, I don't remember how to remember that number. 38. It's not really that like crazy of a number. Like you can remember 5 as carboxylic acid. All right, 38. Damn, nothing's coming to my mind to remember 38. So yeah, you could tell like which way this reaction is gonna go. It's obviously gonna go to the left. So you could probably do this. It's gonna go to the right. It's gonna push to the right. And then if you were gonna do last step, if you're gonna physically add acid, the last step would be acidification, where hydronium comes in. That's the final step. If you wanted to make this normal again. Um, and then your final answer would be this. See, you see how this is the same, and then you'll obviously generate. Don't forget to do this, like regenerate it. So yeah, that's you see how the final answer. See, this is why I'm always like this is why I always remember this mechanism because it pisses me off. Like why we do the same thing twice. We get this answer and we already got it here. Like why do we do it twice? And there's obviously a reason. I don't know the reason why, but just remember do it twice. That's it.